welcome to my channel. We have a function y equal to ax raised to power n to differentiate with respect to x. We will write that this is called the general principle and is the general method in which you can solve differentiation. We have different methods of solving differentiation. We have number one, we have the general method. We have the function of function, which is known as chain rule. So it is known as chain rule. Then the third one, we have the product method. We have the quotient method. And we have the implicit differentiation. These are the differentiation we are going to go through in my videos. So the first one is the general method, and that is the first principle. It says that if y is equal to ax raised to power n, to differentiate this, we have dy over dx because we are differentiating with respect to x. So it's the same thing as the function of x, which is the general formula says that use the power and multiply the coefficients and subtract 1 from the power. That is n times as, subtract 1 from the power. So we have that the general formula is ax and sn minus 1. So this is the general formula, the general principle of differentiation. It is the first method that we are going to do. So this is the general principle of differentiation. So let's start differentiating. For example, if they want you to differentiate, find dy over dx in, for example, if they give you 5x raised to power 4 plus 2x raised to power 3 plus x raised to power 2 and the dy dx, that is the differentiation of this. So how are we going to do? With the general formula, we use it and solve this. Now, use the power and multiply the coefficient, then subtract the power by 1. That is it. After doing this, in all these things, you've gotten your differentiation. So dy with respect to the x, this is your y. If y equal to this, then find dy dx. So this is your y. Then let's get the dy dx. With respect to x, you say 4 times 5. 4 minus 1. That is exactly what is here. Plus, what is here? 3. Say 3 times 2. X raised to power 3 minus 1. Plus, you come to this place, you have 2 times x, 2 minus 1. Come to this place, you have minus 4x. Oh, minus 4 times 1, because the coefficient of here is 1. Times 1. Okay, let me say 1 times minus 4. X 1 raised to power 1 plus 0 times 9. Why is it 0 times 9? Because if you look at these coefficients, if you look at the powers of x here it has a power of 1. Here it has a power of 2. This is a polynomial. This is power of 4, power of 3, 2, 1. And here it has a power of 0. That means the x here has a power of 0. You get me? So anything raised to power 0 will give you 1. So that 1 times 9, that's why we got 9 times 1 is equal to 9. That's why we wrote 9 without putting x raised to power 0. So that is why we come across putting 9 here without the value of x. So what are we going to do here? Why differentiating? The power of x here is 0. So use 0 to multiply now 9. And even when you minus 6, nothing, because 0 multiply any number will give you 0. So that is why in differentiation, when you are differentiating a constant, the constant will give you 0 whenever you are differentiating. So let's start solving this. 5 times 4 will give you 20x. 4 minus 1 will give you x raised to power 3. Plus 3 times 2 will give you 6x. 3 raised to power 3 minus 1 will give you x raised to power 2. Plus 2 times s will give you 2x. 2 minus 1 will give you s raised to power 1. So there's no need putting it. So 1 times minus 4 will give you minus 4. X 1 minus 1 is 0. And x raised to the power 0 is 0, 1. When you are, okay, let me put it. X raised to the power 0 plus 0. Because 0 times 9 is 0. So we have here 20x raised to the power 3 plus 6x raised to the power 2 plus 2x minus x raised to the power 0 is 1. So minus 4 times 1 will give you minus 4. And 0 is out. So this is the differentiation of this y. So dy dx is equal to 20x raised to the power 3 plus 6x raised to the power 2 plus 2x minus 4. So that is the differentiation. From our general principle, we have that this is what is given to you as the value of y. So you start differentiating. If y is equal to 2 over x, 2 okay, this is our general principle. Let's put this in indices. You know that 1 over x squared in indices is the same thing as x raised to the power minus 2. If you want to make it not to be fraction, you put it this. Because of the inverse, you put it. So let's apply it in this. So we have 2 bracket x raised to the power minus 3 plus, we are still getting our y. And we have 1 over 2. This is 1 times x raised to the power minus 2 plus, okay, minus 5x raised to the power minus 1 plus 6. This is our value of r. This is x raised to the power minus 2 because 1 times this is this. So this is the value of our y when I want to make it to remove these inverses, the fractions. So what am I going to do right now? You use the first principle, this principle, the general principle, to solve it. So use the power. We have 2 times minus 3 x minus 3 minus 1 plus this, you have minus 2 x minus 2 minus 1 all over 2. This one you have minus 1 times 5 x minus 1 minus 1, and the last one plus, when you are differentiating constant, you have 0. So here we have minus 6 x raised to the power minus 4 plus the 2 here, we cancel 2 here, so we have minus x raised to the power minus 3. Minus times minus is plus. This you have 5x minus 2. How does you leave it? So this one we're going to have to put it so that we will remove this minus sign, raised to the power minus sign, put it back to this place. Okay, what are you going to do right now? So you have minus 6 all over x raised to the power 4. I put it back to the normal state it was before now. So here minus times plus is minus. So x raised to the power, you have 1 over x raised to the power 3, and this one is plus 5 x raised to the power minus 2, x to the power 2. Sorry. So this is the dy, the differentiation with respect to x of this question.